Well, hello everyone, and welcome back to Adrian's Digital Basement. This is part 2 in the Southwest Technical Products Corporation 6800 computer system video series. It's sitting right here on the bench behind me, and boy is that name a mouthful to say. I'm just going to call it the Southwest 6800 computer, or Southwest, or anyways. Yes, if you haven't seen part 1, I really recommend you watch that first. It's sort of an introduction to this computer, which me personally, I pretty much knew nothing about when I got this thing. So watch that first, and in this video, I'm gonna dive into seeing if I can get this computer even working. Completely unknown, the state of it. I have no idea if this thing works or not. So let's try to get this thing up and running and see if I can, well, do anything with it. So without further ado, let's get right to it. First, let's talk about the bare minimum that's going to be required to get this computer working. I do this because it's totally unknown the condition of all these cards, so it's best to eliminate any that we don't need to have in here in case those are going to cause an issue. Besides the chips on the CPU card needing to work properly, and let me just plug that into the front here, the console board needs to work as well, but so do these chips on the motherboard. And I'm a little worried that a couple of them on here have been socketed, so perhaps there have been some issues with this address decoding as well. Luckily, these all appear to be normal 74LS logic, except these two ICs here, which are 8835s. So maybe those are some kind of bus transceivers or something like that. 74LS logic would be easy for me to find, but those, on the other hand, if these are bad, I'm gonna have to order some online. It looks like some of the other boards use 88 series chips as well. This is the DS8833 here from National Semiconductor. And on the floppy card here, there's some 8602s, and up here we have some AMD 9324s. Now you might be asking, like, what's going on with all these weird part numbers? Back when this machine came out, there was no standard for TTL logics, which is what we consider 74LS stuff now. 74LS existed, but all these competing ones also existed. They're all TTL, so they can talk to each other. And in a lot of cases, the ICs are actually interchangeable with each other, like there will be an equivalent part from one of the other standards, but not always. And I think on my Apple II Plus repair video, I ran into a case where I had a bad bus transceiver on the motherboard, and I had to build a little adapter to use a 74LS part in place of whatever the original part was, because the pinout was not compatible. So I'm just gonna keep my fingers crossed right now that these special parts are working, and this machine is gonna just fire right up after this long. Okay, so for this serial console card, it is my understanding that it needs to go into this slot here, which is slot 1. And there is a key, by the way, on all of these slots, so you can't accidentally plug it in the wrong direction because of that key. And even these serial connections here have a little key on them as well. And actually, before I plug in the motherboard power connector, I'm just gonna leave that off to the side here. I'm gonna plug the mains power cord in here. And I'd like to use the oscilloscope here on the bench just to make sure that those unregulated supplies on there aren't too ripply. So let's power this up. There it is. We have a nice glowing neon light inside the power button there, which sort of flickers, but that's okay. That's like a character. And if I touch this right here to that pin, 100 millivolts per division, and we're barely seeing anything, that is just really, really good. And then right here on the power connector, there's two more unregulated outputs. We have this one here, which is plus 15.2 volts, and this one minus 15.1. So that means that these diodes here are working properly. And incidentally, I used 35 volts rated caps. Originally they were 25 volts, but plenty of headroom on those two caps to do filtering there on those legs. Now, I'm just curious, if I shut the power off here, minus 15.1, when I turn this off, is it falling? We're still getting minus 15.1. Well, are those caps like so capacious that they're able to keep providing that power, or is this power supply working even when the power switch is off? Let me pull the cord out of the wall. Nope, cord's out of the wall. And we're still getting 15.5 volts. These two Nichicon caps, I guess, have such low ESR that they're just able to keep putting power out. Okay, let's check this these other rail here. Yeah, it's 8.59 and it's not really falling either. So all of this here doesn't have a bleed resistor on it, so even when the power's off with no load, it just sits there. Well, I don't feel like connecting the motherboard to this power supply, even though it's off right now. So I'm gonna connect this 8 ohm resistor across this large cap here. So let's see, that should do the trick. Yes, we are almost to 0 there. And let's look at the -12 here. And it's been a few minutes, but we are still at 15.1 volts there on the -12, and yeah, 15 on that one as well. So let's use this big resistor here and drain this down. All right, so first I'm gonna add a little deoxit here because this connector is very crusty just because this computer has not seen the best conditions. We'll plug that in. And actually, before I power this up, I just taken the 2 cards out. I'm gonna power it up with the motherboard connected. I'm just gonna check this voltage regulator right here. All right. Getting 5.13, so that's good. Let's turn that off. It drops very slow, but there we go, it dropped pretty quick. Okay, back in with the CPU card. Now these front slots are not specific. It can go into any one of them. They're not mapped to like a particular slot number like these back ones. Now what I'm gonna do is take the oscilloscope and I'm just gonna hook onto this first pin right here, which according to the legend on the front of the case, which you can't see, that is data bit 0. And let's hit the power and take a look at the oscilloscope and let's see if we see activity. That doesn't look good. That's not what I would expect to see. Let's try data bit 1. That is what I would expect to see. What is going on data bit 0 though? Oh yeah, okay, so I don't think this computer is gonna work. I'm gonna power the machine on and I'm just gonna go through each one of these pins with the probe here. So there's 0, which is definitely not working. 1 is good, 2 is good, 3 is not looking good. I mean, that might be fine. It's pretty low. 4 looks normal, 5 is normal, 6 is normal, 7 is good as well. And now let's check out the address lines. I'm just gonna go through them all really quickly and point out any that look bad. All right, these are what I found that look suspect so far. Let's start with data bit 0. So there it is. It never goes above that, and I assume there's supposed to be highs there. I mean, I'm positive there is. So something is holding that low. And then here's data bit 3, and it looks very similar to 0, where it's sort of stuck low all the time. And when I hit reset, kind of drops away for a second, and 0 will do the same thing. Here's address line 15. It's always stuck high. It's possible the CPU is only ever writing to stuff in the higher part of memory because of course the CPU card has that static RAM on it and the ROM, which are all up in the upper half of memory, which means I think address line 15 will always be high. But then here's address line 13. Now that doesn't look right. Notice how it's kind of like dropping down here and that doesn't seem right. So I think 13 is bad and then 12 is always stuck down here at ground. And when I reset the machine, it does go high, but I feel that the driver on the CPU is probably not working because that should be going all the way to high. So I need to look to see if there's buffers on this card here, the CPU card, or what's going on exactly, because clearly something is wrong there. All right, so luckily there's good documentation for this machine and the schematics are available, but luckily it's such an easy design here, I don't really need them to know what's going on exactly. So these pins right here, or on the motherboard here, are the data bits. And remember I saw that data bit 0 and 3 looked screwy. Well, these two chips here, they seem to be buffering all of the data bits right there. So there could quite well be a fault on these, and these are DS8835N. All right, so there it is, a tri-state quad bus transceiver doing 4 bits at a time for each one of these cards. So we're seeing that data bit 0 is looking like it's not working. What I need to do is figure out on here, this is data bit 0 right there, it goes to that pin. I need to find the equivalent pin on the CPU, and we'll take a look at that on the oscilloscope. One of the cool things is because I can stick this into any of the slots here, Then I can probe the CPU quite easily with the oscilloscope here, so I can just get to the address lines and the data bus lines right on the chip without it being totally inaccessible like in a chassis. Alrighty, so there's the CPU. On screen, I have the CPU pinout as well. So why don't we probe pin 33 here. All right, so there's data bit 0. Now you notice it's up here at 4 volts. That's fine, but you see this part here that's in the middle? That could be floating. That just be, the bus could be floating right there. The CPU could be trying to talk to, for instance, the card that's on here, like the serial card, and maybe it's just not getting back what it expects, and that's the floating part. And then these are low, it's being driven low by the CPU or one of the other parts on this board. Let's zoom out a little bit. Yeah, so that could be normal floating. Let's take a look at the other pins. So that's 0, there's 1. Yeah, see, it's doing it as well. So that's just floating. I think that's normal. That's 2. That is 3. So 3 on the CPU looks totally fine, but 3 on that bus transceiver, like if we go down to the bus down here, so let's see, here's pin 0. Oh wait, that looks fine now. Wait a second, what? Could there be a bad connection on this motherboard? I mean, I have it in a different slot now. Yeah, okay, so 0 is fine. 1, 2, and 3 is fine as well. Okay, I guess we had a bad connection there. Well, with that said, let me go through and check all the other connections now. All right, we're on address line 15 and everything looks high, but I remember I said that that could be completely normal. And address line 13 now looks completely normal as well. Look at that. And address line 12 was the other one that was problematic, and that one looks perfect as well. So everything appears to be working here. Just when I said that these connectors on the motherboard were robust and not troublesome, it was acting up. But you see, a little troubleshooting by just checking the signals on the card showed me that indeed, actually, things were working. Now, one thing that I can do to try to help the situation is take a little bit of sandpaper and just lightly sand down all of the pins on these connectors here, just to kind of rough them up and get some of this oxidation off. I think that will help the situation a little bit. I'm gonna go do that right now. All right, I took a little bit of sandpaper here and I just went over the pins on the main 50 pin connectors and then this one right here for the console card, just to clean that off. And then I used some Deoxit on a little cotton swab and just wiped off all the grit that was left over. And yeah, a lot of gray oxidation came off. Hopefully that fixes the situation. Okay, CPU board back in. I'm gonna put it into one of these sockets further away here so I can access it, like that. And then let's plug in this serial console card. See if we can get this thing coming up. Okay, I'm probing data line 0. Let's turn this on again. We have activity, folks. This is exciting. And the nice thing is we see some changing activity on the data bus lines. That would imply that the CPU is actually doing something, like it's running some code or something like that. Well, on the back of the machine here is the serial port, and the lab PC actually has an RS-232 port on it. So I'm gonna connect right up to this, so we're not even going through a USB thing. And I am going to connect to COM1 300 baud. Let's hit open, and let's see what happens. Ah, we have nothing. I'm gonna shut the power off and I see that it's connected to pins 1, 2, 3, and there's a couple things that are looped on there. And if we take a look at the pinout right here, pin 1 of course is ground, which matches up with what I see happening here, and that is definitely the ground on this little card. And pin 1 is transmit and pin 2 is receive. So let's use the oscilloscope here and we'll hook onto these pins and see if we see any characters being transmitted when I turn on the power. All right, so we're getting about -10 volts on here, even though the system is off right now, and that is just coming from those capacitors there. So when we turn this on, okay, it definitely went low. So it was these two pins here that were connected. Let me see if I can find the schematics for this little board and see if we can see how this is supposed to work. Okay, a little Googling around, I found the manual for the MPC serial control interface. And here it describes what each of those pins do on the connector. So R0 is the RS-232 output. RI is the input, voltage activated input, which conforms to specification, is the input to use when trying the computer system. All right, and on the board here, it was R1 that I was seeing, I don't know, -15 or so volts, but R0, I wasn't seeing anything on. And usually with RS-232, I think you should be seeing a negative voltage on both. And basically the computer on one end will drive it to ground, and then the other computer will do the same to transmit back. Okay, then it goes on to say how to configure the card for RS-232 operations. So you need to have a jumper between the T1 and the TC pins. So with this thing connected, so a jumper between T1 and TC, okay, that is done. Okay, you also need to connect the C1 or CI pin to the CO pin. CI to CO, okay, those are looped. All right, and scrolling down here, here are the schematics that I was looking for. So let's see, the RO, it looks like it goes between +5 volts and -12. All right, so the multimeter is here. Let's power this on. First, I'm gonna check that R0. What are we getting on R0? R0 right here. Oh, we are getting -14 volts. And the other one, R1 or RI. Okay, this is the one that is not getting anything. Now, wait a second. Let's check schematics. Okay, RI is right to here. So I gotta try to find on this page. So that's this. It goes into IC5. Well, I'm gonna have to look that up. It's probably like an open collector. All right, with the power back on, RI is, oh, it's still 0. You know what? Maybe the whole time the problem is my connection from the bench PC. Maybe that's what's going on here. I'm pretty sure this is actually connected and working, but maybe it's not. So one thing I know for sure though is RO is the output. So I'm gonna bring up the oscilloscope again, which we've obviously lost connection to. Power it off and on. There we go, yes? Okay, there we go, working system. Okay, powered on. All right. Do we have any activity here? So this should be pulled up to, I don't know, like 5 volts or something when the computer tries to, when this thing tries to transmit. And I'm assuming when it powers on, or hit reset, it should do something. So I'm gonna put single shot on again, but there is absolutely no activity. I just realized, of course, that one of the problems might be I have it in the wrong slot. Like I'm assuming it goes into this slot because I think I've seen pictures where it's in this slot. It doesn't actually say in this manual where to install it, but it does say here that you have to finish the motherboard first. So let's go check out the motherboard assembly instructions. Maybe it tells us where to put this card. And in the motherboard installation instructions, here's the information on the I/O ports. Remember how I said that these slots here were mapped physically, like each slot is mapped into the address space. And I think we can see that right here. I/O port 0 and I/O port 1 control interface. And that would indicate slot 1 right here. And then there's 2, 3, 4, 5, 6, and 7, which you can see are all of these different I/O ports. So wherever you plug a card in, it's gonna be mapped into the equivalent I/O port space here. So yeah, control interface, definitely, it goes into slot 1. But either way, it does appear that this card's not doing anything. And the only thing I don't know for sure is that when you turn on this computer, do you just get like a little prompt, or do you get nothing until you push enter? That's what I'm not positive about. Okay, so what do I know so far? This is in the right slot. The voltages seem to be okay on here. So I started taking a look at the schematics for this control board. Now there's a couple chip select lines that go to the 6820 here. There's the I/O line, and I did probe that with the oscilloscope, and it's definitely being selected, and that's the select logic on the motherboard. But there's also this enable pin here, which goes with the clock phase here. So this input right here, phase 2. And when I looked at that pin on here, which is going to pin 25, I didn't see anything at all, nothing. So over on the motherboard schematics, and I love how this has like a bunch of handwritten notes on here, whoever built this thing. So this is what's coming from the system bus here with the CPU card right here. And it goes into IC5 here, and that comes out and it goes to some other stuff, and it gets buffered again, and then that generates that phase signal on this bus. And I'm definitely not seeing anything that's on the connectors or on the card. So there's something going on right here. Now let's start right here at IC5. Now when we scroll down, we can see which IC is what because it's not marked on the board. IC5 is this one right here, and it's this one right here in this socket. So I have the multimeter connected to that phase 2 clock on the lower part of the motherboard where the CPU card is. Should be going to pins 2 and 3 on this chip right here. Now on the motherboard, if I touch it, there's 2. There's 3, we're definitely good. But on the chip itself, it's good on pin 3, but it's not on pin 2. And that's really crusty and corroded looking, and that socket might just be bad. or the chip is bad. So I'm gonna pop that chip out and we'll take a look at it. So I don't think necessarily the chip is bad, but the socket might be, especially just because of corrosion or whatever. Okay. All right, so it's looking a little crusty on the pins here. So why don't we use the sandpaper, which I had handy, and we'll sand this down a little bit. These fiberglass brushes can also come in handy just to try to polish things up a little bit. So this is looking a little better. The pins are a little mangled now because I've bent them up on the sandpaper. Let's pop a little Deoxit into the socket there. Looks like it's got gold contacts in there. This could be a problem under the motherboard as well. I've tried to polish these pins as much as I can. The chip is just in really rough shape. Now let's check the continuity. Yep. Okay, there we go. So we're getting continuity now. I might as well remove this chip here and do a similar process, at least put Deoxit on the socket. Yeah, it's looking a little crusty as well. All right, I sanded the pins a little bit on this. Pop this back in here. Just checking that I put them in the right way. All the notches are facing that way, that's good. Okay, back to the schematics for the serial card. So I'm looking at pin 25 on this board right here. So 1, 2, 3, 4, 5. Okay, I'm on it and I'm gonna turn the power on. Alrighty, now we're seeing that signal there. So I'm gonna clip the oscilloscope right here on the output. Let's see if we see anything. I'm gonna single shot this and we'll turn this on. Okay, there we go, everyone. It is working! When I hit single and we hit that, we see it. There it is. So let me go back a little bit. We'll hit single again. I'll hit the reset button. Look at that. I don't know if that's actually like what we should be getting. I don't really see enough activity there. Oh wait, no, there we go. I forgot. This is like 300 baud, so it's super, super slow. So I'll single shot again. There we go, everyone. Look at this. I think this is actually working right now. Oh, okay. Let me turn off the power. I'm gonna unhook the scope and we'll get the serial cable again, which I'm not sure this is actually working because I still wasn't seeing the correct input voltages, but I don't even know what the serial port on this computer does exactly. Okay, power on. Okay, we got nothing. All right, so this is the serial cable from the back of the computer and I can confirm that pin 3 on here is actually at like minus 12 volts or so, which makes sense because pin 3 on the computer, which is the input, is also, well, it should be driven down to that by the computer, right? Now, what I don't know is that when I plug this adapter in, I don't know if this adapter works because I don't even know where I got this. So let's check what's happening on this. So I should see pin 3 low, and you know what? I don't. I see pin 2 low. So it's almost like this adapter here is a no modem adapter and it converts from 9-pin. I really forgot my serial basic while recording the video. There are two types of serial equipment, DTE or data terminal equipment, or DCE, data carrier equipment. It's basically the terminal is your computer and the carrier equipment is the equivalent of the modem. That's back in the day when modems were supplied from the phone company. If you're gonna connect two DTE devices together, basically two computers, you're gonna need a null modem adapter. We go back to PuTTY and we load COM1 at 300 bits per second, and we open and we turn the power on. Oh, yes, look at that. We got something. Let's get the keyboard and hit enter on this. Okay, we're not getting anything here. Why is that? What character are we seeing? I'm gonna change the font, make it a little bigger and easier to see. Okay, we're seeing an asterisk. And you know what? That's what the manual said we're supposed to see. When we power it on, if we hit reset, we should see it again. And we do. Okay, transmit is definitely working. But when I hit keys on the keyboard, I am not getting anything. All right, I've loaded up the old TerraTerm program here. This thing is ancient. Like, when did this, 1998? Oh no, 2019. Wow, the font it's using though, looks like it's a Windows 3.1 amp. All right, let's see the serial port settings. Here we go, 300 bits per second. I know it's 8-bit, no parity, 1 stop bit if you're running at 300 baud here. Alrighty, let's turn the computer off and let's turn it back on again. Okay, we got a star. Oh, M 0000. All right, this is showing us RAM. This is actually working. I can't believe it. Okay, so there's no RAM installed down there. So how do I exit out of this? I think I push a random key. No, space. I am shocked that this is all working. All right, back on the motherboard PDF, we have RAM right here at 8,000, and then we have the ROM here at E1000. So let's take a look at that ROM here, E1000. There we go. I guess this is the ROM here. This is what we're seeing. Now, obviously I can't just type stuff in here to change it because this is the ROM, right? But I certainly can in that RAM. Now, I don't know what part of the RAM is being used. So if I hit a space, does that exit out? Yes, it does. Okay, M, and let's look here, A1000. A1000. Okay, so 89. I mean, I don't know what byte I want to change in here because, you know, could break this thing. Okay, well, anyways, I need to look at the manual to see how this machine language monitor actually works. But for sure, this machine's working. It's taking commands. We were able to look at the ROM and the RAM. It's freaking working. So far, the only problems with it, well, was that dodgy socket that I just had to deoxit. And then we had the problem where the slot down here just wasn't making good contact with the CPU card. So when I took it out and moved it here, it just magically started working. So that is a testament to the reliability of this old stuff. This machine is from 1977. It was left out in the moisture and whatever that made this transformer go bad. And other than those two capacitors I had to change out, this thing freaking works. It just freaking works. That is so exciting. That is so unbelievably exciting. Well, that's going to be it for this video. I am so excited to get this computer working, and there were no actual faults. It was just dirty contacts, which isn't really that surprising considering how much kind of filth was inside that machine when I opened it up. And clearly it's been exposed to the elements, and that doesn't do good things for the contacts, especially the IC legs and stuff like that. But luckily with a little sanding or a little deoxit or a combination of both, you can get things working again without having to replace any components. And that was definitely the case on this machine. So in the next video, I'm going to be looking at the rest of those cards that came with this thing to see if those RAM cards work and the disk controller. And of course, there's another parallel port card as well. You can't really do very much with this thing without those RAM cards because all it's got right now is I think 128 bytes of RAM, which is just enough for the monitor ROM to run. But what is kind of cool is that there are some memory tests that I saw online that can run inside of that 128 bytes. So you don't need functional RAM to actually check that your RAM cards are working, well, other than that 128 bytes, which appears to be working properly. So get subscribed so you don't miss any future updates on this machine. Next up, I want to thank my patrons. Their support means so much to me, and you see their names scrolling up the side of the screen. If you want to become a supporter or a patron, you can do so at the link in the description below. I'd love to hear from any viewers who have used one of these machines in the past. I posted part 1 early access to my patrons, and I had several people comment that they had one of these machines when they were younger or used one in university, or there are some of my patrons that actually still own one of these machines. Although they've been in storage for so long, they'd have no idea if they work or where they really are anymore. So yeah, really, like I said in part 1, I had honestly never heard of this machine, never saw a picture of it, and I didn't know that there was a lineage of 6800 and 6809 machines that all stem back to this computer. So just very, very cool. Anyhow, thanks very much for watching. Thumbs up if you like seeing all the usual YouTube-y stuff, and that's gonna be that. So stay healthy, stay safe, and I will see you next time. Bye-bye.